It feels like there is another circle that, it will pass through the centers of all the three.
So what I am thinking is, uh, basically, if you take like the mirror image of it and finish the circle,
Oh!
you will have an hexagon.
Oh my God. Oh. Yeah.
So from that you can find the radius. You still have to do some calculation. So that is how I'm thinking.
But how do you know it will be a regular perfect hexagon? Okay, there are 6 sides. Oh, center to center, center to center. So this. This length has to be equal to this length. So all 6 sides are same. So Shiva asked a question, okay. So if I have a circle of some radius, how many of R, some R, and I have another circle of R2. So I have a big circle, let's say 100 centimeters or something. Now I have a small circles around it. So what should be the radius such that I can fit perfect amount of circles around it? Like is there a relationship between the radiuses?
So
You worked on this?
no, not on this particular problem, but we know that if that the second, okay, so I have the central coin. If the other peripheral coin radius is same as the central coin, you can fit 6.
Oh, is it?
Now I'm assuming the question is you are having smaller coins around the central coin.
Yes.
I mean, I don't know. Like
Ah,
out of intuition, I'm thinking it would be like it should work for any 1 by n. My guess.
oh,
My guess, but yeah. So you necessarily want uh, the outer circles to be smaller? Can they be bigger?
no, it is not necessary. It can be any R1, R2. What is the relationship between R1, R2? That will make this happen.
Oh, then it is like see if you have so I'm thinking of the question in this way.
Huh.
So if I arrange like any, okay, assume I am taking the circles of radius 1. I can arrange the I can arrange 3 circles so that they all touch each other.
I can arrange 3 circles in a line.
No. Like
yes.
they touch each other.
Yes.
So in the gap the gap between, I can always draw 1 circle.
Oh, is that obvious? Wait.
Okay, so yeah, it's like you can stop sharing. I can share my.
But I still haven't solved this. But wow,
So,
that
okay,
idea was so nice.
you want to think about this for a while? Like you can work on it.
This specific problem. I'll take 5 more minutes and then we'll switch.
Okay.
Okay. I loved the idea of hexagon. Wow, what a poetry. Yeah, I just saw that it will be a hexagon. I mean, like roughly, because like I see all the sides will be same and I see all the angles will also be same. This is like an ugly way. I don't like it.
There's an easier way.
Oh, there's an easier way. Huh? Oh my God. Wait. What is this angle? 90, 30, right? Oh, so it'll be 2, 2, 2. 2 plus, oh my God. So it will be 4, right?
Hmm.
This total is 4, so this is half. Oh, this is 2 then.
No.
Wait. Oh, no, 2 plus 1, 3.
Wait.
Right?
So this is my
Wow.
solution also.
We'll
Yeah.
see the thing. Uh, yeah.
Working is how the answer.
What is this polypad link? Oh, what? What is shows? Oh, fine.
They have the answer. Next.
Oh, nice. 1, 1, 1, 1. Oh, wait, what? But how did they get this? How did
Uh,
they?
no, it's the same thing that we are doing.
But how did they know that this will touch this?
Okay, I guess by congruence of triangles, you can show that these two triangles that are formed, like
Oh, this. Oh,
that, you can use that to show they both will be congruent. How
oh,
they are equilateral, that I am also thinking.
this is same. This is same. Mm, okay, the angle sort of is the same. So we have side angle. Fine. So the third side should also be same. There is no other way, right?
Wait, how do you know the angle? I mean, the angle is same only, but how do you know it?
Right. Oh, good question. I was.
I mean, yeah. So I'm also working on like a very intuitive level. I'm not bothering
Yeah, true.
intuitively. I can.
Fine. You're asking how is this angle same? Okay, this angle is there. How do I know it bisects this to the center, right? Oh my God. How do I know this is in the center? If I draw a line through the center, uh, cen so the radius, if I draw a line from this center to the center, can draw a line. That is fine. How do I know it will bisect this? Can we argue some symmetry? If I cut it in half, this is symmetric. It's not.
Yeah. I mean, I would accept that actually. It's intuitive, you know. But I'm just wondering if there's more
Fine. Yeah.
like,
Something to lock it down, right? Mm.
yeah, like I'm just looking at the proof. Intuitively, I can see why this is true. I am just like,
Yeah, it is. It feels strange, no? Like, why would the angle bisector of these will pass through the center of the big circle? And also, yeah, why would, yeah, basically that. So I'm just thinking if this circle was somewhere here, then it is not true.
so yeah, basically we need to use the fact that the circle is also, I mean, the left and right circles are touching the semicircle.
Uh, that somehow we have to use.
So basically, the 3 points in which the left and right circle, each of them are touching. So the 3 points of contact will be like 120, 120, 120.
Yeah.
Um,
What do you mean by 3 points? This point, this point, and this point, huh?
no. You just take one of the bottom circles, say the left one.
Left
Say,
one.
yeah. So now that is having 3 points of contact.
This one, and this one.
Yes.
But which angle do you mean is 120?
So if you just draw the radius to the point of contact.
Radius of what? The radius of the big circle to the point of contact.
No, radius of the small circle.
Oh, fine. Oh, okay. These three things will be 120, 120, 120. It will be divided into 120s.
But
I see.
I mean, it is not obvious.
Why is that true, right? So now if the right, like the sizes of the circles are different, it could be like a small three things here,
Correct.
right? We have to use the fact that the radius is also big enough that this thing is actually forming a semicircle. So I think these two will play a role. These three circles and it passing through the center will be true even if they are not big enough. Even for small circles, it will be true, right?
Yeah, if they are
Intuitively.
symmetric, it will pass through the bisector.
It will pass through the bisector.
So yeah, I guess I can only use the hexagon argument. That is, take
Yeah.
the reflection. It will be a regular hexagon that we can prove.
Yes. I think that is fine. All right. So how do you prove it's a regular hexagon?
Okay, so basically in that figure, I mean, if
Huh.
you take the reflection of it,
Hmm.
yeah, again it's like really symmetric.
Yes.
So all the sides should be equal,
Huh.
and that will make it a regular hexagon directly.
Uh,
So now, then it means that yeah, it's made up of equilateral triangles, and yeah.
okay. Fine. Oh, this is an equal. Oh my God. Oh, fine. This is an equilateral triangle. So how, wait, one thing I'm just interested in, how did you use the symmetry argument to show it's a hexagon?
Uh, right. So yeah, just imagine your yeah. Can you actually take the reflection of this part? This figure, you know that if you rotate this figure by 60 degrees or something, you will get the same thing. So it means on the sides, like the line segments
Right.
joining the centers are identical.
Okay. Yeah, fine. If I rotate it by some amount, it is, yeah. So all these sides are same. That is easy to see. It's like 1 all the time.
Mm.
And for angles, it's like, so these are three balls. Okay, so this is the angle. So these are again three balls.
Mm.
So this angle should be the same as this angle.
Mm.
So I was seeing it in that sense. Yeah, basically it's like symmetry thing only. Mm, I see. Yeah, I don't see it this way very easily. But it's interesting to see if there are like how do you show that three circles touching each other as well as the so is it true for even if the circles are of different sizes? No, right?
Ah,
No, then it will be different. So it has to be three identical circles.
mm.
So if three identical circles touch each other as well as the bigger circle, then its angle bisector, yeah, I mean, you know what I mean by angle bisector, will pass through the center of the main circle.
Mm.
Hmm. Okay. Maybe something we can prove later on. Do you want to change? Do you want to try some other question or think about this?
No, like you mentioned this question, right? That
Huh.
is central circle and peripheral
Yes.
circle.
Yes.
So now I was actually thinking of in the opposite direction. That is, uh, suppose I have like circles of radius 1. I can
Ah.
arrange three of them so that they touch each other.
Ah.
And in this gap, I can always draw some small circle which will touch all three.
Ah. Now I
So now,
can. Sorry. Carry on.
so in that way, it is like the peripheral circles are bigger than the central circle. But they are
Ah. Yes. This is true.
now I can do the same thing with like 4 coins also, 4 circles also.
Oh, 4 circles you keep, and oh, fine.
Now this I can do for like any n.
Okay, but after some time it becomes hard, no?
No, no, no. So it's really a matter of drawing an n-sided polygon, right?
Oh, n-sided regular polygon will always satisfy that, right? Oh my God, what a... So yeah, this will be in the half of this. This is the okay.
So now I am just claiming that it is like you can always have 3 circles around a circle, 4 circles around a circle, or any n circles around the circle.
Around the circle. Oh, fine.
Huh. Now it is a matter of finding that relation between the radius.
Yes.
So when it forms a hexagon, it is
Huh.
like the radius are the central circle and the outer circles have same radius.
Wait. Central circle and the outer circle have same radius. This was 1. This is 2. This is 2. Oh, this was 3. So this is also 2. Oh my God. So everything is same.
Yeah.
Uh, so for others, oh, fine. For 6, n equal to 6, this is the case. The number of circles, outside circles increases, the bigger the inside circle.
Correct. Yes.
Uh, wow, nice. Wow, what a...
So I assume it's always possible to arrange like any number of circles around a circle.
Yeah, yes, that is true, right?
Hmm.
Yeah.
Yeah. Now, yeah. Like initially, I made this random guess that for any like 1/n radius of the central circle will get outer circle. That might not be true. That
Okay.
relationship might be some random thing. Might go into irrational numbers or something.
Uh, right. So how do we find that relationship?
So for like 3 outer circles, we can probably calculate the radius of the smaller inner circle.
Okay.
I mean, I guess there might be like even some standard formula for this, but we can try to work it from first principles.
Yeah.
So
So I have this thing. If I know the length of this, I'll be able to figure out.
uh, correct. So now basically this is an equilateral triangle, right?
Ah,
So now that center point is going to be like the circumcenter and centroid.
circumcenter and centroid. Yes.
Right.
Ah,
So okay. So now first question is for the equilateral triangle, can you find the length of the median
length of the what? Median. Ah?
or the altitude? So here both will be same.
Oh, this one.
Uh,
Yeah, I can find. This will be half. This will be a by 2. Is there a nicer way of putting it?
no. You are on the right track only. You have to apply Pythagoras theorem. So
Ah, oh, this square plus this square equals this square. h square plus a square by 4 equals a square. Three by root 2, root 3 by 2. Wait, root 3 by 2 a.
Correct. Right. So now this is the length of the median. Okay.
Yes.
So now, okay. Now, if you happen to know this property of centroid as to how it will divide the median, then you will know the length of that segment.
Length of this one.
Correct.
Oh, but I don't know. Is this 3:2 or something? It feels like that. Sorry.
Okay.
It feels like a
So,
1/3.
okay. So the centroid will divide the median in the ratio 2:1.
Okay. So 2, 1. Okay.
Ah.
So out of 3 parts, it is 2 parts. This. So 2 by 3 times root 3 by 2a.
Correct.
So there's 1 a by root 3. Oh, so this is a by root 3. Now our thing. So our thing is a by root 3 minus a by 2.
I think it will be
By 2.
a minus a by root 3. It was. No, I mean, can you just like draw the figure neatly? You will be able to figure.
Right. So this is a. So our circle comes like this, right? So the radius of the circle is a by 2. So now we need to see this length. I know this is a by root 3.
Correct.
So now what is this? This is a by root 3 minus a by 2.
Correct. Yeah.
Huh. Wait. So this is the wait. I just want to see if. So I know this is true. This will come like this. How do I know that this thing will pass through the center of the circle? So I have a doubt. So have we shown that there exists a circle here?
We haven't shown, but it is possible to prove.
Oh, it is possible to prove.
Yeah, I'm also thinking how.
So far, I think if, for me it is very, almost I think it is very clear that among any regular sided polygon, I can always fit circles like this, and it'll fit nicely. But so far, an existence of a circle inside this is something I don't see. I can intuitively see it as possible, but I don't see like a concrete thing for it.
No, so you can do it by the same symmetry argument.
I was. Okay. First, I draw this circle. Oh. So now, can I say this is equal to this?
Yes.
How do you say this? I'm just trying to put a nice word to it.
Okay, so for one thing, you know that both the medians will be of same length.
Yeah, this and this are of the same length. Yes.
Okay, so you will know that the meeting point is that centroid.
Yeah.
Right. So now you know that like the similar segments will also be the same. That is from centroid till the end of the side.
This and this are same.
Yes. And
Okay.
the remaining part is just like 1 minus that is just that minus
Oh,
radius.
fine. Okay. Then okay, fine. Then in that sense, this and this are same. Okay, fine. Understood. So if I have such 3 points, then I can fit a circle around it, right? Oh, very good. But what if okay, the circle won't pass through this any of the other things, right?
Hmm.
It'll just touch this and this, but it won't. If I take this as the center and draw a circle, it will touch this and this for sure. But would it cross the circle anyway? No, right?
Hmm.
How do I see it?
Like your question is why should such a circle exist? Is it
No. In the sense, okay, sorry.
okay? Right now you are working on whether that circle will kind of intersect the outer circles instead of just touching them.
Yes. Here it. So I know it will touch this, but at any other point, will it cross it? It won't, right?
Hmm.
It should not. But why am I getting such a question? If I touch two circles together, it should not cross at any other point. I think that should be fine, no? If it is just touching at one point, why would it touch any other cross? No, I don't think it will work. Yeah, fine.
No. I mean, it is. I think your question is a valid question only. Yeah, like I don't have a proper answer for it.
Yeah, but I think it is fine in the sense. So this circle is, I know the circle will just touch when the radius is this.
Hmm.
My small circle will just touch this circle when my radius is appropriate. So when it's just touching, there is at no other point will it cross the same
Correct.
circle, right?
Yes.
It is
So yeah,
touching,
so
then
if
it's
that
fine.
we have shown that the radius of that small circle or like the distance of the point is the same. So
Ah,
effectively, it's the radius of the small circle. So it should
yes.
only touch the other circles, not
Touch, cross, yeah. Fine. I think this should be fine. Okay, great. Done.